Hopefully you found these answers to the questions on this page. If you didn't, stop, look back at your definitions, look back at the examples, and make sure you can identify all these different types of angle relationships before moving on. Because what we're going to do next is take these ideas and we're going to look at a postulate. Now in this postulate, the important part is if two parallel lines are cut by a transversal, then we believe the corresponding angles to be congruent, which makes sense. If line L and line M are parallel, and to note that in a picture, if you ever see a small triangle on those lines, that's indicating that those lines are parallel, being given to you. Then we believe the corresponding angles are congruent, which makes sense. Because if the lines are parallel, they're not changing direction. So when you cut that transversal, an angle 1 that's in the exact same location as angle 2 is going to have the same measurement. Now this is a postulate. We're not going to prove it. It looks to be true. It looks to be true in every example, so we accept it without proving it. But if we accept this one postulate, we should be able to prove more things about angle relationships and parallel lines. So this you might want to add to your theorem sheet for the end of this test, or the end of this unit. Turn the page, let's look at our next idea. Now I'm telling you that L is parallel to M, that's all I'm giving you. And I'm saying, prove to me that angle 2 and angle 3 are the same. So let's walk through the proof and then see if we can't write a nice two-column proof to support this idea. If L and M are parallel, the only thing I know about parallel lines being cut by a transversal, so let's first identify the transversal. That'd be the line coming through the middle, hitting both lines at two different points. I notice angle 1 is on that transversal, and angle 3 is on that transversal. I identify those as corresponding. So using the postulate we just said, I know that angle 1 and angle 3 are congruent. Because if I have parallel lines cut by transversal, my corresponding angles are congruent. But I also know there's a relationship between angle 1 and angle 2. Angle 1 and angle 2 are vertical, so I could say angle 1 and angle 2 are the same measurement or congruent to each other. But if 1 is the same as 2 and 2 is the same as 3, then I could cut out that middleman of 1 and say that angle 2 is congruent to angle 3 using the transitive property. So I do know that 2 and 3 are going to be the same, and I have reasons for justifying that. And I wrote them down in a logical way, so when I go to write the proof, it will look like this. All you gave me was that L was parallel to M. That was my first statement because it was given to me. Statement number 2, I said that angle 1 and angle 3 were congruent because they were corresponding. But corresponding are only congruent if the lines are parallel, so I have to mention all those important parts. If parallel lines are cut by a transversal. And while this seems like a lot to write, it's important. If parallel lines are cut by a transversal, then your corresponding angles are congruent. That was just the reason for number 2. Number 3, we use the idea that vertical angles are congruent to say that 1 was the same as 2. And then statement number 4, and I apologize for getting messy here, was we cut out the middleman and said 2 is congruent to 3 because they're all congruent to each other, which is simply a transitive property. And that is how you're going to write a brand new proof with statements and reasons about a picture with parallel lines and transversals. That's why we spent all that time in chapter 2 getting used to writing those ideas down. Now I have solid proof that if I cut two parallel lines with a transversal, angle 2 and angle 3 will be the same. But angle 2 and angle 3 have a special name. They're alternate interior. So I've just proven that when you cut two parallel lines with a transversal, all the alternate interior angles are going to be congruent. So I don't have to use this again. If I ever see an alternate interior again, I'm going to say they're congruent because of this theorem that I'm going to add to my theorem sheet. At the bottom of the page, we have another very similar idea. We have L is parallel to M, and that's all we know. So I'll mark that with my triangles to remind myself these are parallel. Angle 1 is vertical to angle 2, so those are the same. But angle 2 and angle 3 are corresponding, so those are the same when the lines are parallel, which they are. So I've noticed that I've marked 1, 2, and 3 all the same. That means angle 1 and angle 3 are the same by the transitive property. So we have a very similar proof. I'm not going to write this one out. 1 and 2 were vertical, 2 and 3 were corresponding, so 1 and 3 are congruent by the transitive property. But angle 1 and angle 3 are alternate exterior. So it also is true that if you cut parallel lines with a transversal, my alternate exterior as well as my interior angles are congruent. So the next time someone asks me if 1 and 3 are the same, I will write this theorem down and use that as a reason. So we use proofs to come up with faster statements, and here we are doing that. The last one is a little bit different though. Angle 1 and angle 2 are not congruent. They are a linear pair, which means they're supplementary. But angle 1 and angle 3 are corresponding, so those are the same. And if angle 2 is congruent to itself by the reflexive property, then angle 2 and angle 3 are supplementary, because if two angles are congruent, then their supplements are congruent. And I can say that 2 and 3 then have to add up to 180. Easier to see with numbers. If 1 was 100, 2 has to be 80. And if 3 is the same as 1, it has to be 100. So 2 and 3 share that same relationship of adding up to 180 degrees. So this one's slightly different. Consecutive interior, we have a theorem that says those will be supplementary. This is how we use a proof. This is how we come up with new theorems. And these theorems I want you to use to try and answer the questions on the next page in the practice of lesson 1. If you want a summary for this lesson, these are the 4 things that I would add to my theorem sheet. The beginning is the same for all 4 theorems, and you must mention that. If parallel lines are cut by a transversal, then we get 4 relationships. Corresponding angles will be congruent, alternate interior angles will be congruent, alternate exterior will be congruent, but the oddball, the consecutive interior angles, will be supplementary or add up to 180 degrees. Know these theorems, learn the angle relationships, see if you can finish the practice questions from lesson 1, and see me if you have any questions. Good luck.